Welcome to First Canada's FTC training series. In this lesson, we will learn how to debug our programs, how to use functions to produce more maintainable code, and ensure that our robot stops when requested. You should have already seen our previous tutorial, where we learn about the basics of op modes. If you have not seen it, the link to the video is in the description and in the upper right-hand corner of the video. Now that you're all caught up, let's get right into this tutorial. Okay, from here, we can start implementing the fun stuff. Our first challenge will be to display the numbers from 1 to 20 with a quarter-second delay between each number. This means the program will run for a total of 5 seconds. As always, power on the hub, connect to the network, and then create a new Java file. For sample, select blank linear, and then set the op mode to autonomous. We are using linear for this tutorial, specifically because it will be easier to illustrate certain concepts, and because we are not using a controller. In this implementation, we will learn a more advanced way to utilize telemetry. This will allow us to print in a scrolling format. We can achieve this using the telemetry.log feature. Simply print the string you would like in the format telemetry.log.add string. We can also set the number of lines it will show of unique data for before it starts scrolling. In our case, 6 lines should be fine. We can do this through the telemetry.log.setCapacity command. From here, we can create a variable to store the number. We can call it number and set its initial value to 0. Then, we can update the telemetry.log command to display the number. Since the command only takes strings, we can use the string.valueOfCommand to convert the int into a string. Finally, we need to find a way to delay program execution for a quarter second. We can use a loop. We can get the current time before the loop starts and wait until the time has reached that time that we have recorded, plus 250 milliseconds, or a quarter second. After that delay, we will want to increment the number by 1. We will also want to put all of this code within an if statement, whose condition is to only run the code if the number is less than or equal to 20. Let's run the code and see what happens. We only seem to get 0, but nothing after that. To figure out why this is happening, let's use telemetry to debug the situation. Based on what is happening, it seems that our delay loop is not working correctly and is holding the program forever. To see if this is the case, let's use two telemetry.addData commands. We want to see the value of target time and the results of get runtime. Adding the appropriate commands to show both those things and then running the code, we can see that get runtime returns the elapsed time in seconds, not milliseconds. So, the program was doing what it was told. It was going to wait for 250 seconds. Now that we know that get runtime uses seconds and not milliseconds, we can easily change the amount we add to target time from 250 to 0.25. By using telemetry, we were able to successfully debug our program, and just like that, we have a bit of code that can print the numbers from 1 to 20. Telemetry is the best tool you can use to debug your code when it seems like it's not listening to what you said. Although the program works, there is something else wrong with this method. The way we delay our code is not ideal. To find out what is wrong with it, let's perform another challenge that will use these delays. For this challenge, we will say the words FirstTech Challenge Tutorials. However, we will do it in this way. After printing first, we will wait for 3 seconds, and then print tech, and then wait another 3 seconds before printing challenge, and then 3 more seconds before tutorials. Seems simple, right? Let's implement it. All we need to do is use the knowledge we already have to make this work. Let's continue to use telemetry.log, and we will use the same style of delay. This would mean a log statement followed by a loop, and the same thing 3 more times. The code is beginning to look a bit cluttered. Let's put these delays inside a function called delay. The function will take a parameter of how long to delay for in seconds, and then instead of a fixed number being added to the target time, this parameter specified by the user will be added to it. That looks much better already. Let's run the program to see what happens. It seems to be working. But hold on, try stopping the program. After about 2 seconds, we get thrown an error, and the entire robot has to restart. Why did this happen? It happened because our code was stuck in a loop, as the error says that it was not able to stop when requested. Since our loop would only stop once the time was up, it would not stop when requested. This can be dangerous to people and our robot, since the error only kicks in after 2 seconds. That is enough time for the robot to hurt or get hurt, and it is not considered safe. This can be fixed. If in the condition of our loop we add an AND statement and say that op mode is active equals to true, this will ensure that if stop is requested, the loop will stop before the time has elapsed. This situation also points out another advantage of having the function. Had it not been there, we would have had to change the properties of this delay across 3 separate places in the code. You can see how this can quickly become a problem in a larger code. Remember to always include a check for if op mode is active in any of your loops so that your robot stops when you ask it to. For everything we just made, there is a built-in command that does the same. It is called sleep, and it halts the program flow for a specified number of milliseconds, and importantly, will quit early if stop is pressed. Feel free to use that function from now on, rather than our custom one. We made this function because there will be times when you will need to loop. Say you run a motor till it reaches a certain position, and in those times you will need to know how to make code that can be stopped when requested. Here is our final challenge to see if you learned all the concepts in this tutorial. Remember, use functions to write maintainable code. Loops must check the status of the op mode, and we can use telemetry to debug certain aspects of our code. We will try to implement the children's game of FizzBuzz. Here is how the game works. Say the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print FizzBuzz. In our case, the modification is that instead of checking the numbers from 1 to 100, we will instead check the numbers from 1 to 20, waiting for half a second in between checking each number. To check that your program stops when requested, you can move the delay time from half a second to 3 seconds. Make sure that you are easily able to change the parameters of the program, whether that be in phrases, FizzBuzz, or the numbers 3 and 5. Hopefully, you learned about writing more maintainable code using telemetry for debugging and how to write code that can be stopped. If you had trouble with the final challenge or just want to check your work, our solution has been linked in the description below this video. In our next tutorial, we will begin to start moving the robot based on the controller. As always, feel free to leave any questions you have in the comments section, and we will see you next time.